Hi guys, and welcome to the fourth part of TinyOS tutorial. In this part I'm going to talk about user button interface that allows you to program for user switches that are available on sensor boards. But you have to note that not all the sensor boards have this user button. For example, in TLSP, beside the reset switch that is partly a standard for all sensor boards, they all come with a reset switch. But TLSP, for example, gives you another switch that you can program it to do the stuff that you want. But for example, the iris mode doesn't come with a switch, so you cannot do that. So for example, in your project you want to have some kind of interaction with the physical board around the sensor board. For example, you may want the user to push the custom button, and this will cause the chip to wake up from a sleep mode and do some process, get some sensor values and send it to base station. Or maybe something else. For example, in one project I had to turn on the mode from a sleep mode while a door of a building opens or closes. So what I did is just wired some wires, solder some wires directly to this button, and I installed it on the door, so when somebody opens or closes the door, the modes will understand that and will do some other stuff. And what is important here, that if you use the interface for user button, then you have to make sure that the sensor board you are using does provide that feature in the underlying layers of the software, TinyOS. For example, if you program for your user button for TLSP, then you cannot compile that same code for iris, because iris doesn't have the necessary codes for that. So I'm going to the Ubuntu and start programming, and let's see how it goes. Okay, so just before we jump into the coding, I wanted to tell you about something important. When you want to start your project, you have to be careful what to choose, what sensor board you want to choose. If you want to interact more with the environment, beside the standard sensors that are provided on your mount, for example, the TLSP comes with temperature, humidity, and the light sensor. But it also has some expansion headers that allows you to add some analog stuff to it. So just something to mention. For example, this iris port, while it has better communication range and stuff like that, it's not very flexible with expansions, and it comes to the point that which programming board are you using. This is the MIP 510, that is the older model. It, as far as I can see, it doesn't have an expansion header, but you have the newer one, MIP 520. It also has an expansion header that allows you to add some analog stuff to it. So that's just something to mention, and you have to be careful. Yeah, so let's jump into the coding. Okay guys, now we are ready to start our TinyOS program for implementing user button. But before that, I want to have a quick side note. If you are using Windows and Ubuntu regularly, instead of installing these operating systems into different drives or to different partitions, you can just easily use a program like Oracle's VirtualBox to install Ubuntu within your Windows environment. It's quite handy and makes life easier. Anyway, let's start. First of all, we're going to fire up the Eclipse. Remember, we're using Eclipse and we're having a Yeti 2 plugin that allows us to program for TinyOS much easier. So when you start the Eclipse, just make sure that you have the perspective on TinyOS and start with a new project. Okay, I'm going to select the project type, TinyOS project. I'm going to name this project user button test, and our target platform will be TLSP. Okay, now waiting for the project to be initialized. Okay, and remember the structure of the Yeti2 plugin. We have to add our source files into this folder. So I'm going to add a new module file, and I hope that you have remembered the naming convention. So for the module files, for your main module file, usually you do like the project name. In this case is user button test, and follow it with a capital C. Okay. Now we have the module section and the implementation section. So in the module section, we are going to introduce the interfaces we want to use in this project. So almost all TinyOS applications require you to use the boot interface. So you have to use the uses keyword, uses interface, and boot. So, and in this case, we want to do it like when user pushes the switch on the TLSP, one LED gets turned on or turned off. So for that, we need to use the LEDs interface. Face LEDs. So, oh no, uses. Okay, now for adding the interface for user button, I advise you to go and check this link. You can pause the video and write it down and put it on your browser. I've already done that. So this link brings you to the documentation for TinyOS, and at the last part of the link, if you put the name of different platforms, you get the specific documentation for that platform. So this time is TLSP. So I'm going to check for a component that allows us to use the user button. So it's somewhere down here, user button C. So this will show you the schematic of the button C component. And as you can see, it has a notify and get. So we have to implement these two interfaces to be able to use the this component. I'm going to add the notify and get to my program. So I'm going to say uses interface get, and if you see again here, this is has a data type of button underscore state underscore t. So we have to provide that also. So back to the Eclipse get, I'm going to say button underscore state underscore t. I'm doing the same thing for the notify interface. Notify, again it uses the button state t. And as you can see, there are some problems. Yeti2 has been was able to find some problems. The first problem is that we haven't implemented the boot event for the boot interface. So I'm going to do that, but just simply clicking it there. And for this one, the problem is that we haven't included the header file for the user button. So what I'm going to do is at the top of my code, I'm going to say include user button dot h. So as you can see, by adding this include statement, we got rid of that problems. So the only remaining problem is that we have to add the notify event. So get doesn't come with an event, so we don't need to do that. So we have the module file ready, but let's make it a bit cleaner. There's a trick that you can put the group of interfaces in curly braces like this. For example, you can say that this is going to be my general interfaces. This is always a good idea to comment your code. So
when you do like this, uses and interfaces into the bracket, then you don't need to write uses for each of them. So like this, then I'm going to do the same thing for this. Yeah. So this is going to be user button related interfaces. So if you had to use these two interfaces for different things, because there are some other components that use these interfaces, you could just simply say as, for example, get button. Then you refer to it later like this. But because this is the only time we are going to use these interfaces, we just leave it like that. Now I'm going to save the file. Just I hate it when the curly bracers are at the end of the line, so I like it like this more. Okay, save it again. Now we have to add the configuration file. And if you remember, the naming convention for the configuration was project name followed by app C. Now we have the configuration file. For most of the cases, we don't need to do something in this section of the code, so I'm just going to say not interested now. Yeah. Now we have to implement the components that we called in the module file. So remember, here we had the boot and lets and get and notify. So for the boot, if you remember, going back here, it was in the main C component. If I find it, main C should be here, yeah, main C. So this is your main C component, and this is the boot interface. So going back, so I'm going to say components main C. There's a bit of typo there, components main C. And no, the first thing you have to do is to refer to your module file as a component. So I'm going to call my module file user button C, and I'm going to refer to it as app, just to be simpler, so I don't need to write this this longer text anytime I want to wire something. So let's go like this. So this is the main module file. This is the for boot interface, and remember we had the also let's see. Now it's time to do some wiring. So how we do wiring, if you remember, we say app boot should be wired to main C. So there's a slight problem here. Okay, I just did this intentionally because we had the problem here. Our module file is user button test C. No, now the problem is gone. Be very careful with those kind of syntax errors, and we have to add the app.lets to let's see. Now we have to add the get and notify wire the get and notify components to the user button component. So how we do that is just like app dot for example, app dot get should be wired to this component, user button C, and app dot notify should be to use same thing. So this means that we are going to use these two interfaces to be wired to these components. And you can see that there's an error here because we haven't called the component for this. So I'm going to do it here. Components, user button, C. So it's always a good idea to group your components. So for example, I can say here general. This makes the keeping track of your program later much easier. So user button. Okay. Now I think that this is ready to go, but not quite, because we haven't done anything in the boot event. So in the boot event, we have to call that the notify interface to enable itself. So just like this. So when the sensor board gets booted up, we enable the notify interface. Now inside the notify action, what we can do is that we can have a if and else statement, because the button state t, this argument is either 1 or 0, and it is defined in the user button header file. I'm gonna show you. So for example, I can say if val equals 1, this means that the button has been pressed. Or else I can say if you don't need to add anything, but just for demonstration I can say if val equals 0, do something else. So if the val is val or value of the button state t is like this, is 1 or enabled or pressed, we're going to say, for example, call let's we're gonna, when the user pushes in, we're gonna let 0 on, and when val is 0, we're gonna let 0 off. As simple as that. But for the sake of code readability, there's a constant in this header file for the user button.h that is button underline pressed. So this equals 1. This is inside the user button.h header file, and for this one there's another case or statement button least. So this equals 0. So it's up to you if you want to use 1 or 0, but I recommend you to stick with the header file, because this is more readable, and if somebody else is looking to your code, they will understand it better. So I think it's almost ready. Now we have to add our make file. So I'm going to add an empty file and call this make file, and remember it should be with a capital M, and all the other letters should be in lowercase. Okay, now I want the component to be compiled to be our configuration file. So user button app C, and I'm just going to add the general make rules, include $, inside the parentheses you have to add make rules in capital. Don't mind this problem, it's with Yeti plugin. Okay, now we have 3 files. Let's see what we done. Okay, so we have interface boot and let's, and we have the interfaces get and notify, and we have the inside the boot event we call the notify interface to be enabled. So maybe you want later in your code, based on some events or based on some timers, you want to disable it for a bit of time. So there's also you can call notify disable also. if you don't want to notify event to be fired up. But we don't do that right now. Okay, and we have in the notify event, we evaluate this value that is passed in. It is in type of button underscore state underscore t, and we check it if it's pressed or is equal to 1 or is released or equals to 0. We do let 0 on or let 0 off. As simple as that. And the configuration file is self-explanatory, so nothing much. I hope that you have understood this procedure, and the make file also. So I'm going to save all files, and let's go to the terminal window and try to compile the program. So let me increase the window. Okay, I had the files in the workspace, into the user button test. I'm going to the source folder. These are the 3 files that we just created. So I'm going to say make TinyOS just to check if it's going to be compiled. We have an error here, so we have to find what is the error. Okay, you need to create a top-level file called NC. So it should be a syntax error, so I'm going to check to see what's going on. Here I don't see any syntax error. Here I don't see any error. In the make file, yeah, here. It should be component, not components. So yeah, this kind of syntax errors are always troublesome. Apparently it didn't save. Let's save it again. Component user button. Yeah, it should be test. Yeah, next time I will choose a shorter name. There's a lot of problem with this Yeti plugin. Okay, now we have the application compiled, and we can deploy it on the TinyOS now. But just because we are using the VirtualBox, I'm going to show you some tricks, or should be obvious. When you run Ubuntu from the VirtualBox, when you connect your TinyOS to the serial port, I'm going to do it right now. You can see that the TinyOS has been recognized by the Windows, but if you go here and try the command note list, you cannot see the device because the TinyOS was inside the Windows. So for finding the TinyOS on the Ubuntu, you have to go to the devices menu of the VirtualBox and go to the USB devices and select this one. Now it will be forwarded to the Ubuntu. So if you do the mode list again, there you can see the TinyOS board has been recognized by the Ubuntu. So I'm going to clear the window and install it on the TinyOS. So I'm going to say make install TinyOS. Okay, we have an error here. Permission was denied because we didn't change the permission to write mode. So I'm going to say sudo change mode 666 and the address to the TinyOS board TTY USB 0. Enter my password. Now if we install it, it will be installed. Okay. Okay, the program is working, and I'm going to my table to show you the result. Okay guys, this is going to be the result of the work that we have done so far. It's just going to be simple as pushing and releasing the button to turning on and off the LED 0, as you have seen in the code. So just as simple as that. But this is not the only thing that you can do with the user button. For example, in my project, what I did was I soldered some wires to the pins of the button itself, the switch, and if you contact those two pins together, then the switch will be in pressed mode, and if you open them again, it will be in release mode. So for example, you can implement some timers in your code that, for example, if the switch is being pressed for example, more than 20 seconds, then you do something. If it's being pressed for more than 30 seconds, you do something else. If it's pressed for 1 hour, you do something else. This is particularly good for example, for you want to keep track of a door being open or closed. So it's very easy to do by adding some timers to your code. So this is not really about the TinyOS, so you have to put some booleans and variables. You have to add an integer, so you add the time to it, decrease the time from it to keep track of how long the switch is being pressed, or how long has passed since the last press. So this is just an exercise for yourself. I'm not going to teach you C programming. It's up to you. Yeah, let's go back to the TinyOS and Ubuntu, and let's see what can we add to the video. Okay, now we are back to Eclipse. I just wanted to show you how you can make your user button more advanced by adding a timer to your code to keep track of how many times how much time the button was pressed, or how much time was passed since the last button press, and stuff like that. Just going to add a timer component. Remember, we are in the configuration file, and we are going to add a new instance of the timer. So timer was a generic component, so you have to unlike the main C and let C and user button C components, you have to initialize a new instance of the timer and wire it. But before wiring, we have to go to the module file and use the interface timer of type tmili. And we have the error here because we haven't implemented the event. So we have our fire event here. Okay, in the boot event, we say we want our timer to be run, for example, for 3 seconds, in 3-second period. So I'm going to call timer start periodic for 3000 milliseconds. So each 3000 milliseconds, the timer will be fired. And here we can do some checks. We can have a button state variable called button state, and then what we can say is that we can assign the here is what the get interface is useful. So we can get the state of the button. So before we add the timer, we didn't use the get interface. Now we can use it just like this. We can say our button state should contain the current state of the button. So now we can say call get. So this will get the state of the button if it's pressed or if it's released. So now we can do some checks also. Now we can check if button is if button state equals button pressed, we can turn on the LED 1. Else, if it's not pressed, we can remember we could use else if and do this check, but else will be evaluate any other cases that is not here. So else we can say call let's that LED 1 off. Here let me change this to LED 1 on and LED 1 off. So so what this adds to a program, it will add if we press the button and we hold it for more than 3 seconds, this part of code will be executed. So you can put anything else here. You can even add more timers and add your custom function and do the stuff you like. So let's see this in action, and I'm going to compile it again. First I will save every file. No, I already saved. So into terminal, see the workspace, see the change directly to user button test, to source folder. Let's list the files. We have the previous build, so I'm going to clean it, make clean. So the previous build is deleted now. I'm going to make install TLSP. So we have an error here. It says that the timer was not connected, and he's right, because we added the timer component here, but we forgot to connect it. So after the timer should be connected to timer milli-C. Or we could just, if you want to add to multiple timers, you can just call them timer 0, and we change this one to timer 0. This is where the as keyword is very useful, but we have to change here also. We have to call this one timer 0, and respectively we have to change the event name timer 0. Okay, now everything is set. Going back to terminal, clear the window, make install again. We have another problem. Cannot find timer at user button this app. 16. Okay. We had to change this to timer 0 also in the configuration file. Now everything should be okay, hopefully. No. Ah, yes. We have to change this one also. Now I hope that everything is okay. Yeah, we have to change the mode to write permission for TLSP. Do it again. Oh. Oh. So at the device. Apparently we have disconnected the TLSP. Okay, now it should be here. Okay. Now I'm going to back to my table and show you the result. So what we just did was adding a timer to our code to check if the button was pressed for more than 3 seconds. It will turn on the LED one, or in this case the green LED of the board. So this is the normal one, pressing and releasing. So after 3 times, because I pressed it after 3 seconds, it turns on. And if I don't press it after 3 seconds, it will turn off. You see, 3 seconds passed, it turns on, and 3 seconds passed again, it turns off. So adding some timers in conjunction with the user button allows you to do a lot of stuff. It's up to your own imagination and your own limits. You can do any possible or reasonable thing with this timer and the user button. Okay, as you saw, our program runs as expected. There was no problems, and I'm just going to tell you that the next part of the tutorial will be about no, before that, something very important I have mentioned in the beginning of the video, because this user button is not existing on some platforms like Iris. If you try to make this program that we made for TinyOS, because TinyOS does have a user button, and in its platform codes inside TinyOS it's defined, there's no problem. But if you try to make it for Iris or any other mode or sensor board that doesn't have this user button, you will have errors. So this is just something you have to know. Don't try to make a program for a board that doesn't have a certain part of the hardware. And yeah, so the next part of the tutorial, I'm going to talk about the radio communication between different modes. For example, from one TinyOS to another TinyOS, or one TinyOS to Iris or Mikazi. It doesn't matter; they are all compatible together. And if you have any question, in my forum, in my website forum, that is eetutorials.com/forum, I have a subsection for TinyOS. So there are some people here. If you have any questions, or if you want to discuss the TinyOS or anything, you can join our forum and put your question here, or try to answer to the other people's questions. And if I have time, or if I know the answer to your question, I will be happy to help you out. Yeah, so this was this for this video, and hopefully I will make the video much quicker, the next video much quicker, and it comes very soon. So thanks for watching, and I hope that you learned something. Bye.